Agent Safety Under the Microscope. The empirical data from the Agents of Chaos study lands alongside a large-scale public competition quantifying indirect prompt injection vulnerabilities across frontier models. The results are bleak. Researchers identified universal attack strategies that transfer across 21 of 41 agent behaviors and across multiple model families. Gemini 2.5 Pro exhibited both high capability and high vulnerability simultaneously. Being a better model does not mean being a safer one. Every defense mechanism tested was bypassed with success rates exceeding 50%. The concealment problem is what elevates this from concerning to dangerous. Since users only observe the agent's final response, attacks can execute harmful actions while presenting completely normal-looking output. As one commenter put it, the answer to whether you can fully sanitize against prompt injection is no, and that changes how you architect defenses. The inspector has to be independent of the system it inspects. An editorial from Unhyped AI sharpens the organizational dimension. Written from decades of cybersecurity experience, it names the pattern anyone in security recognizes: excitement, convenience, overconfidence, selective amnesia. Agents land inside whatever the organization already is. Its permissions sprawl, its vague ownership, its accumulated workarounds. Shared drives nobody meant to expose, service accounts nobody can fully map, tokens with more scope than anyone intended. Once agents traverse that terrain, ordinary weaknesses stop being local defects and become shared exposure. In multi-agent settings, weakness travels. A bad instruction does not stay put. A spoofed identity does not stay local. A compromised prompt does not remain one component's problem. Responsibility diffuses faster than return compounds. The fastest path to durable ROI, the author argues, is not autonomy first and control later. It is authority, identity, containment, and intervention designed in from the start. Procedural defenses and sandbox breakouts. As the attack surface expands, the defense tooling is at least trying to keep pace. A new paper introduces RLM-JB, a jailbreak detection framework built on recursive language models that treats detection as a multi-stage procedure rather than a one-shot classification. The pipeline normalizes and deobfuscates suspicious inputs, chunks text to reduce context dilution and guarantee coverage, screens each chunk independently via worker models, then aggregates cross-chunk signals to recover split payload attacks. On Autodon-style adversarial inputs, RLM-JB achieves 92.5, 98.0% recall while maintaining 98.99, 100% precision and false positive rates between 0.0, 2.0%. The key comparison, GPT-5.2 used directly without the procedural pipeline achieved only 59.57% recall on the same attacks. With RLM-JB wrapping it, recall jumped to 98.0%. A 38-point absolute gain. That suggests robustness is largely determined by procedural coverage and compositional reasoning rather than by the screening model's raw capability. The trade-off is latency, up to 3x processing time compared to baseline. Against published guardrails like Granite Guardian 3.0 F1, 0.821 and LlamaGuard 2 F1, 0.758, RLM-JB's best configuration hits F1 of 0.985. Meanwhile, the practical sandbox security conversation is heating up at BSidesSF 2026, where a talk on pruning and defending AI agent code interpreters walked through a real sandbox breakout disclosed in AWS Bedrock AgentCore. DNS-based command and control, S3 data exfiltration, and an interactive reverse shell, all achieved from within what was marketed as sandbox mode. The talk covers Claude Code, Codex CLI, Cursor, Docker sandboxes, and E2B, noting that sandbox means wildly different things depending on who built it. Some use microvams, some use comp filters, and some just allow list a few broad domains and call it a day. The most honest observation, even when sandboxes exist, they often degrade productivity so much that people disable them. And the best security control becomes a human in the loop who is tired of pressing enter. For those who want to test their own RAG stacks against these attack patterns, an open source attack and defense lab for Chroma D and local LLM setups has been released for exactly that purpose. Claude Code extends its reach. Anthropic continues building Claude Code into something that looks less like a CLI tool and more like a platform. The latest addition is Channels, an MCP server architecture that pushes external events into a running Claude Code session so the model can react to things happening while the developer is away from the terminal. Currently in research preview, Channels supports Telegram and Discord as two-way bridges. A message arrives from Telegram, Claude reads it, does the work against local files, and sends the reply back through the same channel. Enterprise organizations get admin-level controls, and a sender allow list ensures only paired accounts can push messages. The key architectural point. Unlike Claude Code on the web, which spawns fresh cloud sandboxes, or remote control which streams the terminal to the Claude mobile app, Channels pushes events from non-Claude sources into an already running local session. CI webhooks, error trackers, deploy pipelines, anything with a messaging interface. Developers who needed this capability before channels was available have had an open source alternative. Claude Telegram Mirror v0.2 WA Quad 6. A native Rust daemon that has been doing bidirectional Claude code, Telegram bridging in production for months. A short video breakdown clarifies the 3 remote interaction modes now available. Channels Telegram/Discord, dev-focused, somewhat hacky. Dispatch Claude Cowork desktop app only, not Claude Code. And remote control official Claude mobile app streaming the terminal. For 99% of users who just want to talk to Claude Code from their phone, remote control remains the answer. On the repo scaling front, one practitioner shared a workflow that stops treating tokens as storage and starts treating them as CPU. A recursive language model gateway loads the entire repo into a repo workspace, writes programs to walk and slice it, builds a compact context pack, then hands that to the model like a precompiled header. Claude and the underlying model suddenly act like they have been on the project for 2 years. The token efficiency theme extends to MCP server management. A new plugin called MCP Optimizer audits which MCP tools actually get used versus which ones waste tokens loading their schemas into every conversation. Reportedly 500+ wasted tokens per session with just 3 idle servers. The plugin converts unused MCP tools into on-demand skills that load only when invoked. Several commenters noted that Claude Code's own deferred tool search already addresses this, raising the question of whether the plugin solves a problem that is already being solved upstream. The bigger strategic picture. Someone reverse-engineered binaries inside Claude Code's Firecracker micro VM and found references to AntSpace, an internal code name for what appears to be Anthropic's own PaaS platform, comparable to Vercel. The strategic play is straightforward. Anthropic owns the LLM, Claude builds the app, AntSpace deploys it. If true, this puts Anthropic in direct competition with Vercel, Netlify, Replit, Lovable, and Bolt, with the significant advantage of owning the entire stack from model to hosting. Autonomous development loops and agentic QE. Codex Autoresearch generalizes Karpathy's autoresearch loop. Modify, verify, keep or discard, repeat. Beyond ML training into everything in software engineering that has a measurable number. Test coverage, type errors, performance latency, lint warnings. If there is a metric, the tool iterates autonomously. Built as a Codex skill, it scans the repo, proposes a plan, confirms with the developer, then enters an unbounded or n-bounded loop where each iteration makes one atomic change, commits it, runs dual gate verification, did the metric improve? Did anything else break? And keeps or auto-reverts. Progress accumulates in Git. Failures revert cleanly. 7 specialized modes. Loop, plan, debug, fix, security, ship, exec, are inferred from a single natural language sentence. Cross-run learning means lessons from failed hypotheses carry forward across sessions, and a pivot protocol escalates after 3 consecutive discards. The architecture is simple enough to be robust. Environment probe, baseline establishment, hypothesis selection informed by prior lessons, atomic change, commit, verify, decide. The question of how you verify what autonomous loops produce is the subject of a detailed editorial connecting classical testing wisdom to the agentic era. While shipping 6 releases of an agentic QE platform in 1 week, the author was reading Bach and Bolton's Taking Testing Seriously, the latest rapid software testing RST framework, including the heuristic test strategy model HTSM. The connection proved immediately practical. A tool prefix mismatch shipped with green CI because no test exercised the interface between agents and the MCP layer. The HTSM categorized it instantly as a compatibility and testability problem. Low observability, the mismatch was invisible until runtime, and poor decomposability, no way to test tool resolution without launching the full agent. The editorial tracks a trust evolution from TDD trust at the function level through BDD trust at behavior level to expectation-driven development trust at stated expectations to outcome-driven development trust at delivered value. Each transition relocates trust 1 level further from code and 1 level closer to the customer. The punchline: a QE swarm analysis found that benchmark runs had leaked junk data into the learning database, inflating quality scores. Tests passed, behavior matched specification, but the outcome was compromised because the data was lying. Classical testing heuristics caught what automated verification missed. Multi-agent reasoning gets a brain. A new paper from the Chinese Academy of Sciences proposes BIGMAS, brain-inspired graph multi-agent systems, which borrows from global workspace theory GWT in neuroscience to organize LLM agents as nodes in a dynamically constructed directed graph coordinating through a centralized shared workspace. The key insight addresses a limitation shared by existing multi-agent frameworks. Agent communication is either point-to-point or encoded in fixed topologies, leaving global task state fragmented and preventing dynamic adaptation. BIGMAS introduces a graph designer agent that autonomously constructs a task-specific agent graph for each problem, an orchestrator with full-state visibility that makes routing decisions based on the complete workspace, and a self-correction loop that resolves errors without aborting execution. Tested on Game 24, 6.5s, and Tower of London across 6 frontier models DeepSeek, Claude, GPT, Gemini, BIGMAS consistently improves performance for both standard LLMs and large reasoning models, with gains largest precisely where individual models struggle most. It outperforms React and Tree of Thoughts across all 3 benchmarks. The result supports the hypothesis that multi-agent architectural design provides complementary gains orthogonal to model-level reasoning. You cannot simply scale your way past reasoning collapse, but you can distribute and structure the cognitive load to push the threshold further out. Small models, big ambitions. Kitten TTS ships 3 new models at 15M, 40M, and 80M parameters, between 25 MB and 80 MB on disk, delivering high-quality voice synthesis on CPU without requiring a GPU. Built on ONNX with 8 built-in voices and 24 kHz output, the smallest int8 variant fits in 25 MB and runs on any machine with Python 3.8. This is Edge TTS taken seriously. The models are small enough for mobile SDKs on the roadmap and embedded deployment, with commercial support available for custom voices. The Apache 2.0 license removes the friction that keeps proprietary TTS vendors in business for most use cases. On the model compression front, FlashMoe claims to run a 397B parameter mixture of experts model on a laptop by loading only active experts into memory, while a new distillation tool called BDistill takes a different approach to extracting value from large models. Rather than compressing the model itself, it pipelines structured knowledge extraction. Pointed at a domain, it generates targeted questions, feeds them to whatever model you already pay for, scores every answer, and exports structured JSON with quality scores and source attribution. The argument is that the real moat is not the model, but the proprietary data that compounds over time. Cross-validated across models, with temporal snapshots showing how model knowledge changed between versions. It runs as an MCP server inside Claude Code, Cursor, or Copilot. The distillation theme extends to QWEN3.52B model distilled from Claude Opus 4.6 reasoning and published as GGUF. Small enough to run locally with reasoning traces inherited from a frontier model. Local models are also pushing into agentic territory. A demo shows Qwen8B and 4B completing browser automation tasks by replanning one step at a time. The smaller model handles each action while the larger one plans the next step. A practical decomposition that keeps latency manageable on consumer hardware. And for the quantization curious, a blind-scored experiment tested whether e-matrix calibration data affects writing style in quantized models. A niche but important question as quantization becomes the default deployment path for local inference. Cautionary tales and trust in infrastructure. CVE2026. 3888 is a local privilege escalation vulnerability affecting default Ubuntu Desktop 24.04 plus installations, allowing an unprivileged attacker to reach full root through the interaction of snap confine the set-to-ead root binary that builds snap sandboxes and system TM files the cleanup daemon that removes stale data from /TMP. The attack requires patience. The attacker waits 30 days for system TM files to delete the critical /TMP. /.snap directory, recreates it with malicious payloads, and during the next sandbox initialization snap confine bind mounts those files as root. CVSS 7.8. The scope is changed, meaning a successful exploit impacts resources beyond the vulnerable component. A secondary finding during the review of Ubuntu 25.10 identified a race condition in the Rust-based utils caroutils ARM utility that could lead to arbitrary file deletion as root. The default ARM was reverted to GNU caroutils to mitigate immediately. Organizations running Ubuntu Desktop 24.04 or later should patch now. The trust architecture question plays out differently in a courtroom. A CEO asked ChatGPT how to avoid a $250 million contract, ignored his lawyer's advice, and lost terribly in court. The comments section offers the darkest humor. Did the other side use Claude? Even ChatGPT reportedly told the CEO that getting out would be very difficult. The tool was not the problem, the judgment was. As attorneys themselves face scrutiny for AI use in court briefs, the lesson remains stubbornly simple. AI outputs are inputs to human decisions, not substitutes for professional judgment. On the infrastructure resilience side, Project Nomad packages Wikipedia, local LLMs, offline maps, and Khan Academy courses into a free, open source server that runs without internet on any Ubuntu machine with a decent GPU. The pitch targets preppers and off-grid users, but the underlying engineering question, what happens when your infrastructure dependencies disappear, applies well beyond survivalism. 2 commands to install GPU-accelerated inference and community benchmarks ranging from refurbished desktops to dedicated GPU rigs.